Okay, Assalamualaikum and hi everyone. Okay, so I'm gonna talk about wave. Okay, so wave, there is two types of wave. Okay, first is transverse and the second one is longitudinal wave. Okay, so for transverse wave are wave whose oscillation is perpendicular to path of wave or direction of propagation. In transverse wave, only crest and trough at the apex of the wave is called crest and the lowest point of wave is called trough. Example of transverse wave, first is light wave, ripple and radio wave. Okay, so next is a longitudinal wave. Okay, longitudinal wave in which the displacement of the medium is the same direction as or the opposition direction to the direction of propagation of the wave. Section where medium is compacted is called compression, and section where the medium is further apart is called rarefaction. Example of longitudinal wave is sound and water wave. Next, I'm gonna talk about characteristic of wave. Like all things, a wave also has their own characteristic that should be known, and that is first wavelength, second amplitude, and the last one is frequency. Okay, so for the wavelength is the distance between one point to another exact point in another repetitive cycle. Example of how we can measure wavelength: first, crest to crest, second one, trough to trough, the third one, compression to compression, next, rarefaction to rarefaction, neutral to neutral point, and the last one is wavefront to wavefront. Okay, wavelength is used to measure speed of the wave and how far can wavelength go at certain time. So the symbol of wavelength is lambda. Okay, so this is wavelength for longitudinal wave. Okay, and then this one is wavelength for transverse wave. Okay, the last one is wavelength for wavefront. Okay, next characteristic is amplitude. Amplitude is the maximum displacement between equilibrium position to crest or trough of a wave. Amplitude determines the magnitude of wave. Higher the amplitude, the higher the amount of energy the wave carries. Amplitude usually equals to 1/2 of the vibration path. Okay, the next one is frequency. Frequency is amount of wave cycle formed in a specific time. Frequency of wave determine the speed of wave move. So frequency is equal to 1/time, where time is period of time in seconds. Okay, common unit used for frequency is Hertz, Hz. The higher frequency of a wave, the lower speed of wave propagates. Okay, there are differences between displacement distance and displacement time graph. Okay, so for displacement distance graph shows position of each particles as the wave propagates along a distance. So for displacement time graph shows the position of particles as the wave propagates at a certain time. Okay, make sure to determine type of graph before answering question in order to avoid being careless and wrong answer.
Assalamualaikum and hi everyone. I'll be covering one of subtopics for this chapter, which is oscillation. So here we will learn damping and forced oscillation. But now let's talk about damping first. So what is damping? Damping is where relaxation is being applied on wave, and this happens due to the amplitude of a wave decreases over the time due to internal and external factor. Such as an example, you can take a ruler and hold a bottom flick the top of it, and you'll notice the ruler will shake widely but will decrease by time. Later, I will explain more about this. So there are two types of damping, which are external and internal damping. So for external damping, this happens due to frictional force of air resistance. And for your information, in every force, there exists a resistive force that acts opposite direction of driving force. And one of the example is air resistance. And for internal damping, due to extension and compression of molecule in the system, so this damping will happen. As example, if a ruler is shaking, there will be a section where particles will compacted and another section where particles is further apart. And where particles in compact section will emit resistive force to make them less compacted, while particles at further apart section will emit resistive force to pull back their neighbor. In addition of these resistive forces will make the ruler shake less widely over the time and eventually will stand still. But there are pros and cons of damping, where the pros are damping makes sound wave reduce over distance, and this will make people hear less noisy by time. And damping also reduces vibration of an object such as engines, and this surely will make the engine less wear and damage. And the cons of damping is driving force need to continuously supplies if want to produce constant amplitude wave. And lastly, force oscillation. Force oscillation is where external force used to counter the damping. That's all. Thank you.
Assalamualaikum and hi everyone. So now we will be talking about resonance. When we think about resonance, remember this, opera singers. Why? Because as we know, opera singer's voice can make the glasses vibrate and some can make the glasses shatter. Why? Well, here's the resonance coming. So the resonance is a phenomenon of an increased amplitude occurs when the frequency of an periodically applied force is almost the same or equal to the natural frequency of the system on which it acts. So in this scenario, the system is the glass and the periodically applied force is the voice of the opera singer. Every object, every object in this world has their own natural frequency. So when an object is placed beside a wave source, what would happen to it? Well, of course, this object will start vibrating because the object receives energy from the wave, just like how humans receive energy from eating. Well, now when a wave source produces wave that equals to the natural frequency of an object, the object will start vibrating at its maximum frequency. This scenario is what we call resonance. The vibration because of maximum frequency. But we're back on the opera's case. We can analyze now that the singer produces very high pitch that is almost the same or equal to the glass natural frequency. This explains why some of us see the glasses started to shake aggressively whenever the singer started to sing. Questions arise: how do we explain the glasses that shattered? Well, as you know now, that glasses vibrate because it receives a frequency that is almost the same as its natural frequency, right? What if the glasses receive a very much higher frequency than the glasses' natural frequency? The answer is the glasses would start to crack, break, and eventually the glasses will shatter. Any system that receives a frequency that is much higher than the system natural frequency, the system will break. This is what happens to the glasses. Now, I can give you an example of this phenomenon. An earthquake. When an earthquake happens, what would you see? The most common answer is buildings destroyed. An earthquake gives a very high frequency that is intolerable for the buildings made by human. That is why after an earthquake pass, you can see so many buildings destroyed because of this earthquake. As I have been explaining about resonance, seems like resonance is a bad thing, right? They're scary. But no, there are so many applications that can be made by this resonance. One of the oldest and cliche application about resonance is the usage of radio. For so many years we have been using radio, but we only know now that it is a resonance application, right? Well, the radio can set to many specific frequency that matches with many specific radio station. Because now, as you know, we have so many radio station, right? Hits FM, Sina FM, Hot FM, Era, that has this radio station have their own specific frequency. That's why the radio is set to a many frequency that can matches with a lot of different radio station. Then when it is the same radio, it is the same frequency as the radio station, the radio will display broadcasted live from the radio station. That's how we explain the application for resonance. Thank you.